Okay, this is a second Excel simulation exercise. In this exercise, we're going to see how to obtain a total loss minimizing optimal inventory level. That's quite a mouthful, but that's what it is. Okay, we're going to see the process of obtaining total loss minimizing optimal inventory level. So let's assume that there are I weeks, okay, 100 weeks of planning period that we use the subscript I to indicate. So week 1, 2, 3, it's roughly about 2 years period. And the weekly demand DI is not known in advance. Okay, you can imagine that you kind of have to rely on some kind of random number generator to fulfill this part because demand is not known. But we have a little addition here. This time we know what's the shape of distribution. It's a normal distribution with a mean of mu and a standard deviation of sigma. So if you start to panic because you're seeing this, don't worry, just stick through this instruction and there will be a time I will be explaining what's the meaning of this one more time. Okay? And yeah, this time we know that demand is not totally chaotic random number. It's not like your maybe TV white noise, all those dots blinking on the TV. It's totally random and not totally. Well, at least we know that there is some pattern we can use to describe the demand. The demand pattern has a mean of mu, right? Mean of mu and a standard deviation of sigma. So this is a central tendency. This is a level of spread. Okay, but in actual problem, you will be supplied by an actual number to figure out what's the total demand look like. And each week begins with a constant inventory level SI. So all SIs, the weekly inventory levels, will be exactly the same because you will be determining a magic inventory level that supposedly help you minimize the total loss. All right, you decide one inventory level. That inventory level will be applied in all weeks. So lastly, there are two types of loss that's associated with this problem. When your demand is greater than the supply or greater than the inventory, that will incur a underage cost. Think about what that means. When your demand is bigger than the inventory, meaning you're likely hit by a stock out situation, right? You have let go a potential sales opportunity just because you don't have enough inventory. That CU here, the cost of underage, basically captures that part. Of course, you'll never see this from your accounting book because no one will really tell you, I couldn't find it. In general, people don't tell, right, store clerk that they couldn't find it. I know some people do, but in general, this is a part where you cannot observe. And the second cost parameter is something much easier to understand. When you have a more inventory than the demand, in this case, we are assuming that your inventory will be dumped in a much cheaper price than the procurement or production cost. Therefore, you're losing money by not being able to sell it on time. So that's our average cost, CO. Okay, that's a CO. So let's move to see what's the question. What value of SI will return the least amount of total loss measured by the following equation? Okay, I get it. I know this is a quite long, monstrous looking equation, but that's actually very simple when you implement it to Excel. Okay, trust me. So let's first take a look at the question itself one more time. What value of inventory level, what magic number of inventory level that you will be deciding at the beginning of all 100 planning period will give you least amount of this? Okay, I think this equation is very long because we're using the maximum expression within the parentheses. We know that this is actually a summation, right? You are summing up all 100 period you're summing up all the loss or cost associated with each week. Let's take a look at this part. When your demand minus SI, that means your demand is greater than your inventory, then maximum expression will pick this part. Okay, therefore this is a positive number you'll be getting from here. When demand is bigger than the SI, we know this is a case of underage. So each unit of underage unit multiplied by the loss associated with that will give you total loss because of not having enough inventory. And this part is the next part. When the inventory is bigger than the demand, then each unit of overage will be multiplied by the overage cost. So this part captures the total overage cost. You will see that in each week, only one of two components will be get activated, because you can't have both scenario happen same time unless you have a DI exactly the same with SI. In that case, everything is 0, which is a perfect scenario. Okay, so you will see this part is much easier to understand when we use Excel simulation. Now, I'm going to move to Excel to complete this part, and then we'll come back and finish this part. Okay, I'm going to open up my Excel spreadsheet. Let's take a look. So we know that in our scenario, we have 100 weeks of planning period. So I'm just going to do 1, 2, and then I'm going to drag it all the way to 100. I know there's an easier way to do this, but let's just stick with this. Okay, I'm going to do until 100 week. All right, and I'm going to jump to the first row. See how I'm doing this. Control upward arrow will help you jump to the very top. And next column, okay, scrolled. Next column, I'm going to put the inventory level. This is inventory level that you will be deciding here. Let's say just temporarily just put 100 as arbitrary number, and all H columns will be using B6 contents here. Double click. Okay, so whatever number you change here, that change will be reflected to all the 100 weeks period. And next one is going to be a demand. So we know that demand in this case has a specific pattern. So let's assume the mean demand is 85. And standard deviation of the demand is 10. Okay? So I'm just going to make it a little more clear. Demand pattern, mean 85, standard deviation 10. So for the demand, we eventually need a random number here. But before I do that, I'm just going to change it to demand randomizer. And I'll do demand. Okay? So you will see that while I'm doing this two-step setup, I'll do round this to 0th digit after decimal point. Okay? I will double click to fill them all. You probably guessed that I'm going to put some numbers that are not integer here as random numbers, but here those numbers will get converted into integer, which is much easier to understand. Okay, remember in our case that the difference between the previous case is that our demand follows a specific distribution. Therefore, you just can't use the rand between, because when you use a rand between, that follows a uniform distribution. But here we're using the normal distribution. The only way we get normal distribution is, or I should say one easier way to get that is through data analysis toolpack. Okay, click it, random number generator, and we're only creating one variable, right? And then we're generating 100 random numbers that follows normal distribution with a mean of 85, with a standard deviation of 12. We're going to start to dump it to here. Random seed is going to improve the reproducibility of this random number generation process. For example, I believe in most cases, if everybody who's watching this simulation video, they're using 65 as a seed, 65 as a seed, all the random numbers you're seeing will be same as mine. That's not guaranteed, but in general, I found that's the case. So the random seed is being used when you try to retain exactly the same random numbers when you generate it next time using the same parameters. Okay, so if you do 85, 12, the seed as 65, and it's very likely that you'll be seeing exactly same random number as mine if you're using, let's say, newest edition of Excel, Windows PC, and so forth. Okay, so if it's not exactly the same, don't worry, it doesn't matter. Click OK. Okay, now you see why I have this additional arrangement, right? Because that random number generator will only give you a non-integer, right? But we need integer here. That's why I generated this as an intermediate step and then rounded up to next integer or nearest integer to make it as an integer. So the only concern I have is whenever I see a negative number here, but I don't think we have any negative number here, so that's pretty good. So the characteristics from this random number generator tool is that the random number once generated, they won't change. They aren't like the Excel function based random number generator. Okay, so for the space saving purpose, I'm just gonna highlight the entire column by clicking here and then right click to hide it, because we just need this part, right? And let's figure out how many unit short in each week or how many unit over in each week in order to calculate loss associated with each week. Okay, so I'm just going to calculate shortage here first. Shortage or underage according to language I used previously. And then here is going to be overage or surplus. Okay, let me change it. All right, so you'll be likely to come up with underage quantity or overage quantity. You'll see that they'll only occur one of two, not both. And then I'll be able to calculate the total shortage cost. I should say weekly shortage cost. All right, and you'll see the weekly overage cost. Okay, once it is done, I'm going to start to get the underage quantity and overage quantity. So let's maybe complete this part first. Oh, I didn't give you what's the unit underage loss, unit overage cost. Let's just use a cost parameter. Say maybe underage as 20 and overage as 12. Okay, when one unit is short, each foregone sales opportunity will make you lose $20. When you sell beyond a certain point, they give you $12 loss. Okay, you can consider this as a cost as well. I'm just trying to distinguish the loss with a cost, because loss won't be able to show up in your accounting book because that's a forgotten opportunity. So that's why I'm calling it as a loss. You can, if even you say it's cost, it doesn't really matter too much. It doesn't really matter a lot as long as you know what you're doing here. Okay, so it's very likely that we'll be using loss in actual chapters, but I just want you to be clear what this is all about. So when you have the shortage here, eventually you multiply that with the per unit shortage cost. You likely do F4 to absolute reference it. Next one is overage cost, multiply per unit. Sorry, do it again. Number of average multiply by the per unit average cost, and then F4. Okay, and then here, total number of underage. So it's gonna be maximum. Okay, it's gonna be maximum between. It's when the open parenthesis, the demand minus this. Okay, as you can see in this case, this will likely return a negative. Right, we have more inventory than demand. Therefore, you won't likely see a shortage here. And 0. Okay, and this part is maximum between this minus this and 0. Okay, so I'll be doing it a little differently this time because you see that there are two parentheses there is a little messy. So once you type max open one parenthesis, you can click and open this function dialog box. All right, and we know the second parameter we're evaluating is 0. First parameter evaluating is the difference between the demand and the inventory level. Okay, so do this minus this. Oh yeah, I didn't need two parentheses. But as you can see, if you can use this function argument dialog box, the process is actually much more user-friendly. So it looks like we have 33 unit short. Is this short? Yeah, we have a bigger inventory. It's not exactly shortage. We have a surplus here, okay? But anyway, this will be 0 again because this is not exactly a shortage. Let me do it again. Max, the dialog box, okay? The difference between inventory level and demand and 0. Okay, so I'm gonna open my formula view mode so that you can take a look before you move on. Okay, am I consistent? I think I'm consistent, right? The difference between demand and inventory, if that's negative, underage is 0. Underage did not happen. And if the difference between the inventory level and the demand is positive, that's overage. So I think I got this part correctly. I'm going to go back and turn it off. All right. As you can see that the cost part is actually being calculated automatically. So once you're done those two rows, you can just double click, fill the rest. Okay, fill the rest. So your total cost or total loss is actually can be the sum of column M and column N, right? Because in each row, it captures loss or cost that occurred in that particular week. We're interested in understanding the total loss. So I'm just going to do total loss. It's going to be sum from M and N. Okay. Again, when you use this way to reference a particular column or columns, you need to make sure there's nothing else than the values. There's nothing else in the columns other than the value that you want to put into the calculation. Okay, so with inventory level 120, this is our total loss. Let's go back to our PowerPoint slide to make sure what our question is. What value of SI, which is your inventory level, will return the least amount of total loss? So again, the entire Excel spreadsheet we've just done in the past 10 minutes is in fact and try to capture this thing. Where is this thing? B17. B17. So that means we need to determine this. We need to decide that one to minimize this guy right here. All right. So your job is to figure out in what level of inventory level this guy can be minimized. So I'm going to increase one more, okay? 121, maybe 122. It's keep increasing, right? Maybe I should try a smaller number like a 40. Ooh, it's even bigger. Maybe 100. Oh, I started as 100. Maybe I should try 68. It's smaller, maybe 60, 69, 70. Yeah. So it's your job to figure out what inventory level this thing will get minimized. Okay, so there is a brute force way of doing it, and there is some other approach you can consider. You don't have to get the perfect answer at this point, as long as you understand what this thing is all about. Okay, and then before I close this video, let's go back and take a look. The second question. What is the corresponding level of, what is corresponding service level in this case? And we learned the idea of service level in the first video. Okay, and to measure the service level, the definition is number of times none stack out. Oops, yeah. I should just use this symbol. So you need to get this number. So yeah, the service level is defined as the frequency of none stack out, right? And we're going to take a look how many times when it is 70 there was a none stack out situation or scenarios. So since we got underage overage unit already calculated, it's probably just very easy to take advantage of this setting. So just do stack out. Just say none stack out. Right? Is there surplus situation happened? Right? Whenever there's a surplus situation happened, that means that's a none stack out situation. Okay? I can just say if, right? If, again, if you like to use this tool, you can do that. If we're evaluating first week for now, if the surplus is bigger than or equal to 0, should I include 0 or no? That's a good question. I think the better way to do it is to evaluate this using the underage. If the underage is bigger than 1, if underage is non-zero, if underage is non-zero, that means there was a stack out happened. Okay, I hope you take some time to think about this. If the underage is non-zero, right? If the underage is 0, there's still be a chance that there's no stack out, right? But if the underage is at least 1, that means the stack out happened for sure. So if this is bigger than 1, we know that this should be 0 this time, right? Should be 1 because we're flipping the condition. We didn't do it this way in the previous video. I hope this makes sense to you. If the underage is true, right? If the underage is true, and then we'd like to express it as a 1. Does it make sense? If the underage is true, that means that's not what we're looking for. We're looking for none stack out. Therefore, if it's a false, we'd like to have 1. Okay? Because specifically we're evaluating week 1. As week 1, this is not bigger than 1. Therefore, this is a none stack out situation for sure. Let's click OK. You just apply it. Every time that there is a surplus, you see that it will be marked as 1. All right. So you know that to do that, to get the number of times of none stack out, you do F all the way to F, and do the service level can be measured by divided by 100 because we do 100 weeks of planning. So only in 12% of the time there's none stock out. I would say customers are pretty unhappy in this case. But let's step back to see whether this conclusion makes sense or not. You see the mean is 85. So most of the times the demand will be around 85, but we're picking an inventory level that's very little, which is 70. So what if we pick 85? Okay, you see that service level in fact increased and total loss has reduced a lot. But is this optimal? 86 maybe? Let's keep decreasing. 87 maybe? I'm not sure. You need to look it up. Okay, to see if we can at least improve this or find out something much better that can help us minimize the total loss. This is the end of simulation number 2. You'll see that I have determined this inventory level. You see that whenever I adjust the inventory level, total loss changes, so does service level. So does the service level. So eventually, if you go back to the PowerPoint slide, it's actually putting those two questions together. When combining those questions together, we're interested in knowing under what service level the total cost can be minimized. I think that is our million-dollar question. I know that I'm asking you to tweak this inventory level because inventory level eventually will tweak the service level. I'm indicating that the total loss is somewhat related to the service level. There are some formal relationships between the service level and the total loss. I'll discuss those in future upcoming chapters. For today, I just want you to finish this simulation and understand those underlying relationships through the simulation. Thanks for your time.